So I see Mr. Raji actually bringing a space-borne technology to be really available at an airborne sense. It's completely about strategizing for asymmetric technologies, where cost effectiveness is obviously a particular component that we cannot deny or skip about. So can you talk more about this asymmetric technology for a SAR context? So a SAR is costlier in its original sense, but I think we do a lot to make it more cost effective and to be adaptable to our Indian sort of conditions, the financial resources or the technical resources that we are ready with as of today. Going really the asymmetric way with SAR, what do you have to say about it?
RISAT was built with a 99% commercial technology.
The RISAT.
Yes, including the FPGAs, there are around 325 FPGAs we used. They were all commercial grade. The power amplifiers were all commercial grade.
Okay.
That to almost 700 of them. And what we understood in ISRO's experience, that it's not the hardware fails, it is the engineer who fails behind the hardware. If it's not a good engineering, then there's a commercial chips, they have actually have to have more reliable.
Okay.
In your house, if a washing machine stops working a day, you will have a tough time. You will forget about CADFEM, you will run after that fellow. Because otherwise you have to wash your clothes.
Yeah.
That will be the situation. So you cannot afford to have failures. Your TV doesn't fail, you have observed?
No, not
They
frequently.
do not fail, they work. Your camera works every day. Whether the PSLV falls or goes, but your camera will work.
Yeah.
So the commercial technology, because of very large user base, they are making it more reliable. So we can take commercial technology, and then if you do a good engineering with a commercial chips, you can actually make a good hardware. And you may be finding, I have built a hardware for space taking a drone. Actually, space is a very nice thing. It experiences disturbance only initial 10 minutes when the satellite is launched. After you reach there, वो शमशान का शांति है उधर. कोई तकलीफ नहीं, but there is not a single disturbance and all. Temperature condition maintenance is benign. But today my fellows are flying this in this weather, rainy. They are flying. They are flying in summer. They are flying in Jaisalmer. They are flying in Himalayas, and it is experiencing very adverse conditions.
Absolutely.
So, apart from this drone itself as a product, I am qualifying the hardware, operating in a very varied conditions. If it survives in all those conditions, malhandling by people and all. And second is that this is a new product which suddenly that people are realizing. Yes, everybody thought synthetic aperture is a costly. We brought it cheap.
Yes.
Everybody thought the platforms are costly. We brought the platforms cheap. Now suddenly the data collection in 5 minutes you collect 10 square kilometer data.
Yeah.
And you can deploy anywhere. For this operation, you don't need a great fellows, In fact, a rudimentary class 12 pass person is enough to do this today drone operation. It has become so reliable.
Yeah.
It is
there are a lot of hobbyists as well.
All secondary resources. And this drone images, it can carry multiple. It can carry hyperspectral. It can carry optical.
Multispectral.
It can have a night vision cameras. Yes. And when you mix all of this information together, it not only brings out exciting possibilities in military application, it brings out exciting possibilities in very day-to-day application, like a crop,
the agricultural
forecast, agriculture applications, a crop estimate, crop disease estimate, or even a forest estimate, or a anything, soil moisture estimate, whether the irrigation is being done
Yes.
properly or
Yeah.
not.
Yeah.
You can now focus on a small areas.
Right.
So this is a one, it is opening up a technology spectrum very different, because just because the platform is cheap, so it can be multiplied many number.
Yes.
And because it is multiplied, the sensors also has to be multiplied. The moment sensors are multiplied, the sensors are becoming also cheap.
In the sense of fusion,
Fusion.
for example.
And the net beneficial is the people
Yes.
who will get this benefit, because the cost reduction in all aspects will be. See, if I have to, I will give an example. If I have to make a very cheapest satellites, I need 6,000 crores to build 60 satellites constellation to give you 1 day data. But remember, with a very fraction of the cost of a satellite, one satellite is actually, we can build
Multiple
almost
drones,
multiple
for
drones,
example. Yeah.
which can be operated, which can be with a 15 minutes notice can be
Yes.
flown.
Yeah. And that deployment can give us an advantage of
It's
fusing
anywhere
sensors.
it can be deployed.
Yes. Yeah.
It is so, it doesn't need a big launch, it doesn't need a big space, it doesn't need a big storage space. It's just, it can be deployed. So it is changing not only just warfare, it is going to change the way the government operates in estimating its resources.
Right.
How the mining companies operates to get these resources estimated. And this is a paradigm shift is happening, and people are just seeing it happening. Probably the earthquake they'll feel within a year.
I think rightly said, Mr. Raji. I mean, technologies like sensor fusion, bringing the SAR to really flexible, smaller platforms like drones, and on top of all this, very wisely using AI/ML technologies as well, will save us from going to cross a financial barrier necessarily, like getting into extravagant or affluent spending, which we may not afford given the nation's other priorities of people welfare as of today. For example, these costlier technologies could be something like really getting too many SARs, or maybe operating them in P band, for instance, which is more penetrative, but it has its own disadvantages. So our point of view is that you can use simulations in this case as well to validate which case is better. And at the same time, for costlier technologies which are not asymmetric in the nature, for instance, about using P bands or using much many more number of powerful SARs in a sense. So that could be a project which can be investigated parallelly. But parallelly, I think we also need AI/ML, we also need sensor fusion and flexible drones to carry SARs, like you rightly said.
I'll take to first AI application there. See, the one is that the building sensor is one.
Yeah.
That is one part of the story.
Yes.
But building data samples, if I say crop application, it should be applicable to dal. It can be applicable to tuer dal.
Yes.
It should be applicable to moong dal. It should be applicable to urad dal.
Sort of crop
it may be
you can target.
for minicut rice. It will be for the basmati rice and all. Now this so much variety, there cannot be one code fits all.
Yes.
So for each of these, they need a different characterization. You see that when I have a small samples, my characterization will be inaccurate.
Right.
Now, as and when we learn more and more data collect, the AI assimilates much better that information to make a more accurate guess than a human being could do.
Exactly.
So
yes.
AI will come, assimilate the information, and offer different varieties, their responses, different daytime and different conditions, and then predict the estimate more precisely than a human being could have done.
Absolutely.
So this is where the AI, and AI is one is the application. Today's date, that AI has come to product development. I'll give you the software development. Today, you don't need a very good programmer. You need a person who can logically think and push the
Think
logical
about the
steps
exact query
to
and the
queries.
workflow.
So nowadays you don't need very good engineer or very good colleges or any such thing. But the skill set, from having a skill set to it has gone to a person who can think logically and put their questionnaires in the proper
Absolutely.
steps.
The art
If
of
you
asking questions.
yes, if you do not know how to put things in proper steps,
You fail.
even AI also will not help you.
Will not help you, obviously.
Neither God nor AI.
Yes. Yeah.
So it has come today, even the film editing, it's a video editing. But if you look at it is not just AI. AI is just a tool.
Right.
It is the person who could imaginatively use it for a case by case basis. Now, for them, which would have been editing in other way would have been a very tedious, it has become fast.
Yeah.
And now his imagination can run amok. Film editors'
Yeah.
imagination can run amok. So this is a big changes is coming, and this unfortunately still in hardware there is no hardware
Yes.
simulation, there is no AI still not there. I hope
But we can expect that.
we expect that, but then even those who write the simulation software, they also need lot of ground measurement points,
Yes,
hardware
of course.
measurement
Yeah.
points.
Like I said,
And
it's
how to get from
complementation.
users to get this data, this all, user designs, unfortunately users will not share their designs.
Yeah.
They will,
Most
that
of
is
them
a
are.
one big
Yeah, yes.
issue for the simulation software to graduate to AI. Until unless the software people do themselves design to create the data points. So this is the issue I see. But otherwise, the software today, I can tell you that the earlier days, even for MOUs, to validate MOUs, to even to legal people, they will not see many things. Or today,
Right.
AI, if you
AI
give
can go
a
through
MOU
everything.
for
Yeah.
Indian condition, they will
Yes.
find out all the
Every
code
clause. Yes.
It
They
may
can
be
really frame
because
them.
if I get a lot of chain of mails, I can summarize and put it in points. So this way also by productivity, administrative exercise, finance, it has improved. And tomorrow it is going to improve, and human being will be now freed from donkey jobs to more horse jobs.
Yes.
That is what
We are
will
getting
happen
smarter. I
tomorrow.
would say it's
It's
not
a
about
smarter jobs.
yeah. It's not about losing our jobs with AI, which
No.
is completely a fictional
It is
idea. I would
completely,
say.
it's a fiction.
It's a misnomer,
It's a
misconception.
totally misnomer.
Yes.
You just say that it is crop, if AI is applied and the crop health is estimated, it will unleash a business of crop
Several
insurance.
millions, in fact, several
It's
millions
a
can be
huge,
unleashed out.
it may be a 10 lakh crores worth of business.
It's about really getting smarter to make
Smarter,
AI work for us,
yes.
in fact. So even a simple LLM model, Mr. Raji, like a chat GPT as of today, can be very gloriously used provided we have the intelligence to give it the right set of questions, which requires maybe certain skill set in the range of metacognition, etc. So you need to use your power of not just understanding first principles, not just understanding basics, but you also have to have a lot of metacognition capabilities in your wired brain itself. So then you can really reap a lot of benefits from a LLM like ChatGPT as well. So that's how AI works as of today. And coming back to my question, in fact, about asymmetric technologies, wherever we did start about, it's more of leveraging CNNs, I mean a particular form of AI called convolutional neural networks, which are going to deal a lot with images, in fact.
Yeah.
So I think CNNs are at the crux of saving us the trouble and the financial burden of using rather much complicated and much powerful, highly costlier optical technologies. Like it could be so powerful hyperspectral imaging or so powerful multispectral imaging. While it is definitely needed in certain projects, but you can just use a camera and a night vision IR alone in certain cases, and use a lot of data sets to train them to be more intelligent using CNNs. So the combination of a normal camera and a IR and CNNs put together can probably avoid us the financial burden of using really so powerful MWIRs, multispectral kind of imagery sets.
See, the AI, ML, they are very useful tools. There are a lot of varieties are there, lot of language models are there. All tools are very good. But you look at, if the tools do not have the right database, the tools will go haywire. So these sensors are actually gives you the right database. So it is like, as I was telling that suppose you have a jawar or and wheat and makai. If you take from camera, from satellite, they all look same. They will similar type of leaf structure, similar green. But if you look through a radar, they will have a different structure or properties, and they will look at differently. So any object has to be identified from both structural properties as well from its color absorption, color reflection properties. It is like, if I want to compare two persons, if you put AIML, if it is not designed in a proper logic, they will say both are identical because both are having two legs, two hands, one head, two eyes, and all they will say. But if it is trained, no, they have to look at a person's height, their facial features, their ear positioning, ear curling, and all. Then they will start discriminating the two persons. So it is important what type of data input has given. Other thing is that it has to be on a target specific the data. I always give a very popular example. For marriage, you need a photographs, which is taken with a very nice photographer. But this cannot turn to orthopedic surgeon. He needs an X-ray. So, but you cannot go for a fixing marriage with an X-ray photograph, or you cannot go other way around to the orthopedic surgeon. So, it is the sensors to be used or information to be used for the target audience. AI, ML per se, this is not the solution, only solution. This with the appropriate databases is the solution. So while the software writes this case of writing a proper AI algorithm, looking the Bayes theorem, applying them and all of that, but if it is not backed by the data, sensors, information, then it is bound to fail. So that is where all the remote sensing sensors come. Sometimes you need a less sensor input when the AI becomes powerful, but both are not fully replaceable with each other.
That's right, Mr. Raji. Using the appropriate technology is definitely necessary. And like you said about the input data requirements, in fact, to build upon AIML models, that's absolutely true. But one other tangent we are taking as of today into that is that we can synthesize a lot of input data required to train a ML model or AIML model. And this synthesizing of data can indeed come from virtual experiments, not real experiments alone, by using and complementing real experiments with a lot of simulations, precursor simulations, something like pre-processing precursor simulations. We can actually generate data from physics-based simulations. That way you can improve the size of a data set.
Yes, I fully agree. In particular case, there are certain cases, not certain, many cases, the physics-based simulation also will very useful. In fact, if it is available, then I don't want to spend money in collecting information.
Yes.
If simulation can do it, in fact, the whole Einstein's discoveries are based on thought experiments.
Thought experiments.
If he didn't have even a simulation tools, it is all his thought experiments only brought him E equal to mc square. This is when it is absolutely true, but even Einstein's theory to verify, one needed a Eddington's experiment in 1927.
Yes.
For this during the solar eclipse over Chile.
That's right.
Now so even a simulation, because see the final market is finally a human being.
Of course.
It's not a software which is the market. software, it is to be sold. And he is not convinced with a real data, then no amount of simulation will not go. He will still insist, मेरे को एक रियल एक्सपीरियंस तो दिखाओ कैसे होता है, सॉफ्टवेयर तो सही है.
Correct.
So that is where this whole dichotomy, when we have a lot of experiments, AI, ML, but when you go to the market, as a developer, it is very interesting, but that this market, that person, he will demand a one real experiment, because after all, he is the person who is going to spend money.
So you brought up a very interesting point, in fact, Mr. Raji, bringing up Einstein and the theory of relativity and the E equals to mc square, energy to mass conversion equation itself. I mean, it is a very theoretical equation in its inception, in fact. So it could be related directly to pure science or theoretical science. And Oppenheimer has taken that particular equation, and well, he went the destructive way for obvious needs to develop an atomic bomb. And as of today, with the same equation, we see that 75% of the electricity in France is because of nuclear power stations, in fact. So let it be nuclear power stations as an application, or let it be an atomic bomb also as an application. And you are somebody who have been dwelling across PRL, Physical Research Laboratory, which studies, let us say, atmospheric sciences, for example, as a fundamentalization. And you have also worked extensively in your pioneering position at SAC, Ahmedabad, Space Applications Center. Both are different places, in fact. And since you are somebody carrying this blend of experience and who efficiently straddled the boundary between pure sciences and also applied sciences, so I would like to ask you about your reflection on how high schools in the earlier times are actually shaping the young minds. I mean, we see that most of the high schools do not even teach these young minds about the simpler difference between what's pure science and what is applied science. And in our opinion, if they are taught so, then they can become better individuals and better professionals. Then you're giving them the right guidance at the right time, and you're then leaving them to choose whether to go for a MSc physics or a BTech in mechanical engineering, and later something to do with mechatronics or electronics as a whole of it. So engineering is applied science in a way, but at the same time, we also need the support in a fundamental foundational sense from pure sciences. So how do you look about this situation for our high schools as of today?
See, let us go into the fundamentals of science. You see, the science is a one, it is actually observation of nature and finding out a symmetry in this observation and making a generalized equation. Surprisingly, even the chaotic universe runs on very simple equations. It is a Hubble's law, E equal to mc square, Newton's laws, gravity, gravitational field, and all. Now, essence of science is an observation of nature. That is the first thing. So this is a one where that is schools actually deficient. That is the maths problems they set it is not realistic. It is a some hypothetical, and it is set in some other one. Or the problems, the certain physics problem they teach it, but they do not do it a very simple experiment. You can teach hundreds of the Archimedes law, but you can simply put a bowl of water and drop something and so that the water rises.
Right.
That as children they could do experiment. So the nature's observation and experimenting with a natural thing to learn science is a key to that. It's not a, but what is happening today, this education system, that they were going for tuition. And this tuition has become so predominant today, it is actually killing people. And I have taken interviews for ISRO for 10 years.
Okay.
Over that time, I have seen that it's very interesting observation. The written examination, it is a 70% boys, 30% girls. They will get selected because that is the normal ratio
That is a normal
in the
ratio.
classes.
Yes.
But of this in interview stage where the questions are asked not about a definitive answer but your idea of approach.
Right.
In ISRO's interview, they never look for a fixed answers. They look for how you
How you
approach a
approach
problem.
it, basically.
And in this selection, we see that of the 70% boys, only 30 to 40% used to get selected, and the 50% girls got selected. You'll be surprised that one of the top space engineers today, actually girls and women. And it's why it happened. We actually, we thought initially it is the people of an 50 age and all, they have it's the parents, they like their daughter more than the sons. That is whether that sort of feeling has come, but when we aggregated the numbers and we thought over it, what we found, these boys are sent to schools and colleges far away. They were sent to tuition schools. And the girls are not sent to tuition schools, they are put in a nearby colleges. So what happens, those who gone to tuition schools, because they were taught 10,000 problems, you ask them one out of this 10,000 problem, they answer correctly. But if you put a 10,001 problem, then they fail. So, that mentally the boys are conditioned to tuition school such a way, they are losing their thought of horizontal thinking. Whereas that a woman, because they do not go to the schools, tuition schools, generally in the village and all of those things, their brain is still free to take it to the horizontal thinking. And I personally feel, one of the ways, now that the government has banned private tuition up to 16 years of age, and I really support this one, that if we want our children to be more asking questions, thinking themselves, so they have to be given free time to think about that.
Absolutely.
And many times, many people complain to me, the children are today using mobile phone. But I say no, because this mobile, they get a much more information than we used to get through
Yes,
books.
much more.
I
at
say
a
that
bigger pace. If you look
even
at the
before
positivity
the
of that.
Gutenberg discovered that printing, before that people were writing in their own hands.
Of course, calligraphy was
And
popular.
even those days, who are reading books, people say, this is not, the writing in hands is the best way to learn things. But this is not today. Those who are writing in hands, before them people used to only engrave in stones. But
Obviously,
that time they would have told, no, that engraving in stones is a better approach than the writing. So as the technology evolves, our medium of reading and information and words, I will tell you very frankly, because nowadays I don't read newspapers, because before the news happens in evening, in 1 hour and X, I get all the newses. I don't have to read a newspaper. So this dynamics is changing, and the students are actually, today's children, having more information.
Right.
And the question is how to channelize, and another most important thing is the ethical quotient. And this is children growth. One, the teachers give a big influence, and another set of individuals who say that is the grandparents.
Yes. Sure.
Than the parents, because the parents don't have time, they are running around. It is the grandparents who can teach you Ramayana, who teach you Mahabharata, they will teach you Radha Krishna story, and they will teach you Jagannath story and all. So this ethical development is needed from your family people whom with you are close. And this closeness, unfortunately, is breaking down today with the nuclear families. So children are missing the company of grandparents, cousins, these mouses and all, where actually they shape their personality and they shape their idea of how to handle conversation with a different level of people. And this is most important, because today the management, I should know how to handle a chaprasi to a big scientist. Because each level, the conversation will be different. And today I see that children from the nuclear families, They do not know how to handle the senior people, even if it's tantrum, it is there. How to handle it. So these issues are there. So these are the issues which I think, both ethics and the science, teacher and the nature observation, more time should be there, and the interaction in the family needs a ethical grounding. And I have seen, that is the ISRO, that the people who are absolutely truthful about money, they will cheat in the numbers, in the technical data, because they will feel, वो मेरा importance दिखाने का है तो मैं data में थोड़ा adjust कर दूँ. But with this, the satellite will fall down with this adjustment.
Absolutely.
So this ethical
Error.
grounding is very much necessary for the scientific temperament. Because finally, it is the end of the day asking right question and relying on the right answers.
So I think I get your point, Mr. Raju. It's about encouraging the inquisition within children without suppressing it. Basically,
Yes.
letting them ask more and more questions within the family. Basically, it could be about mythology, it could be about any other subjects which can come legendary from the family itself, out of the legacy or the legendary state from the family itself. So I think that soft skill oriented inquisitive development has to be on par with the hard skills they could acquire later in the times. Yeah, going on another tangent and addition there, it's more about also understanding at the school level itself that there is a difference between publishing a paper in the nature journal versus publishing it in a ASME journal, for example. So while the nature journal brings to you effects like, for example, Zeeman effect is absolutely pure science, and then the atomic clock that has been out of that, a spin-off from that, is absolutely an applied science. So there is definitely a contribution from both sides. So maybe while teaching physics in schools, they should tell these young minds that, well, a Raman effect is something which you can go deep into, specialize into if you want to be somebody like that, or you could specialize into something like a Zeeman effect evaluation, writing it yourself, deriving something yourself, versus you could also be an engineer who could build an atomic clock. So this is how engineers work, and this is how the physicists or the fundamentalists work. So in order for them to get the knowledge adequate to choose their career, I think straddling between and explaining them both sides of the pure science and the other side of the applied science is equally important.
See, I have handled both scientific people, also engineering people. And they have a one thing common, that you have to plan properly. Even a theoretical physicist, when he does a lot of thought process and then goes through a lot of mathematical processes and then finally concludes in a theory or then publishes. This is exactly happens with an engineer. He also thought processes, then he finds out the process to implement them, a physical principle to implement them on a mechanical world, and then goes to make the appropriate devices which is actually activated by a particular physics. I remember that Sankaracharya of Puri, once I met him, and he gave a very fantastic definition of innovation. He says, whatever product we see before us, these cameras, we may think they're made of metal, semiconductor. No, they're made here first. Somebody thought of a product like this, and then he made this yantra or the instrument, or which can be theory, when this. And the thought process is mantra, and the yantra, and the process of making that instrument, converting a thought to a theory, the thought to an instrument is a process. This is called tantra. So mantra, tantra and yantra, these are the process of innovation. if you have a mistake in any of the process, mantra, if you do not have a proper thought process, though even with the right tantra or the production process, you will get a bad output. But if you have a very good thought process, but if you don't have a realization process or tantra, you will also get a very bad output. So to get a good product, you need to have a good thinking, and you should have a good thought of the process of realization of it.
Absolutely.
Together, that makes you the basis of innovation.
Thanks, Mr. Raj. So I think just to wrap up our really valuable Vendays was this particular interaction, I'd like to say that inquisition is the key to any sort of progress. And when you come up with questions from, let's say, pure science, or when you come up from questions with applied science, there are valid simulation softwares which can give you answers, but again, garbage in, garbage out does really apply. So for example, when you turn your attention to fundamental sciences, we do have photonics based softwares like numerical, for instance, wherein you can use those to be able to gain foundational knowledge for a lot of other optics. I mean, the Raman spectroscopy as a Raman effect phenomena, or the SPR, other phenomena of the optics as well. So surface plasmon resonance or other plasmonics, all of these can indeed be evaluated at that scale using fundamentalized, more ab initio sort of softwares. And then you can go up onto a macro scale with other softwares, like it could be SPIOs, ray tracing cases, etc. But to just conclude, maybe innovation has always been the key to the success of any progression. And you can use simulation softwares or LLM model or AIML tools, all of these as vehicles to channel your inquisition to a particular area. So I would like to that way conclude and culminate this particular session with a famous Sanskrit quote, Sparthaya Vardhate Vidya. So it's like when you have a lot of inquisition poured in, your knowledge automatically glorifies because of your indigenous inquisition. That's what the saying is to be in Sparthaya Vardhate Vidya. So with that, we call it a wrap. And really thankful for this most valuable rendezvous and a lot of your pioneering times being poured into this conversation. Thanks a lot.
Thank you very much for this nice conversation.